LiveLink for SolidWorks allows us to create geometry directly in SolidWorks, import defined parameters into COMSOL, and perform parametric simulations. Hello, and welcome to my channel. This is Armin. Let's get started with the tutorial. In this tutorial, we'll start by modeling a pipe in SolidWorks. I'll begin by selecting the front plane and clicking on Sketch. The units are set to millimeters. From the Sketch tab, I'll expand the ribbon, choose Circle, and draw two coaxial circles at the origin with approximate dimensions. Next, I'll define the geometry dimensions. Using Smart Dimension, I'll set the inner circle diameter to 50 millimeters and define the wall thickness as 2 millimeters. Once the sketch is complete, I'll click End Sketch to view the pipe's cross-section. Now, I'll move to the Features tab, select Extruded Boss/Base, choose the sketch, and set the extrusion length to 300 millimeters. After clicking Apply, we now have a straight pipe modeled in SolidWorks. Next, we need to define parameters for each dimension so they can be imported into COMSOL and adjusted later. To do this, I'll expand Boss Extrude 1, click on Sketch 1, and select Edit Sketch. I'll double-click on the inner diameter dimension and type a parameter name, for example, DI. A globe icon will appear, indicating Create Global Variable. Click the icon to confirm. Then, delete the numerical value. Press equals, select DI from the list of global variables, and confirm with the green check mark. You'll now see the sigma symbol next to the dimension, showing that it's been parameterized. Let's repeat the process for the thickness. Double-click the thickness dimension, type T, and create a global variable. Remove the current value, press equals, select T, and click the green check mark to confirm. The sketch dimensions have been defined correctly. Now, let's add a parameter for the pipe length. I'll simply right-click on Boss Extrude 1 and select Edit Feature. Then, I'll remove the value 300 millimeters, type L, and click the Create Global Variable icon. After that, I'll assign L as the dimension. Everything looks good now. All key dimensions are parameterized and ready for import into COMSOL. The geometry setup is complete. Let's save the file. Before getting started, we need to check the add-ins to ensure that COMSOL is linked with SolidWorks. Click on the gear icon, go to Add-ins, and make sure that COMSOL Multiphysics is enabled. If everything looks good, close the add-ins window and launch COMSOL. Now, I want to perform a structural analysis. Of course, you can choose any physics interface you need, but for this case, I'll go with Solid Mechanics. Click on Model Wizard to begin. Since the geometry is 3D, I'll select 3D, then choose Solid Mechanics under Structural Mechanics, and click Add. Next, click on Study, select Stationary, and click Done. To import the geometry, we'll now connect SolidWorks to COMSOL using LiveLink. Right-click on Geometry 1 under the LiveLink interfaces, choose SolidWorks, and then simply click Synchronize. You'll see the geometry appear in the COMSOL graphics window. The geometry has already been imported, but the parameters haven't come through. Now, I want to import the parameters into COMSOL. I'll expand the Parameters in CAD Package section, and as you can see, no parameters are listed yet. We've defined 3 parameters in SolidWorks, and importing them is very simple. First, maximize the SolidWorks again. Then, right-click on the root node and select Parameters. A new window will open showing all the parameters defined in SolidWorks. Hold Control and select the 3 parameters we want to bring into COMSOL. Then click Add. These parameters will now be imported into the COMSOL model. Click the green check mark to confirm and return to COMSOL. Now I need to update the geometry. In the Synchronize with option, select Active Document, then click Synchronize again. As you can see, the 3 parameters have now been successfully imported into COMSOL. You can find them under the Parameters 1 section. It's a good idea to add descriptions for each one, for example, thickness, length, and inner diameter. Using these parameters, we can easily modify the pipe dimensions directly in COMSOL. For instance, let's change the length to 500 millimeters and click Build All. As you can see, the geometry updates immediately based on the new parameter value. Let's go back to the Parameters 1 section and change the length back to 300 millimeters. Then click Build All Geometry. This change is also reflected in the SolidWorks model. Now, let's perform a simple structural analysis. First, I'll add material by right-clicking on Materials and selecting Add Material from Library. From the recent materials, I'll choose structural steel. Click Add to Component, then close the material window. Next, it's time to define the boundary conditions. I want to fix one end of the pipe, so I'll right-click on Solid Mechanics, select Fix Constraint, and choose the bottom face of the pipe. Now, I'll apply a stretching force in the Z direction. Right-click on Solid Mechanics again, select Boundary Load, and choose the top face of the pipe. Change the load type to Total Force and enter 1,000 newtons in the Z direction. It's time to generate the mesh. Click Build All to create the default mesh. The mesh looks suitable for this simulation. Finally, navigate to Study 1 and click Compute. The solution is now complete. Now we can perform a parametric sweep to investigate how different parameter values affect the results. Right-click on Study 1 and select Parametric Sweep from the menu. In the Study Settings section, click the plus sign to add a parameter and choose the one you want to vary. For example, length. Note that these parameters are unitless inside the sweep settings, as they are assumed to be in millimeters based on the parameter definitions. Let's solve the model for pipe lengths of 200, 300, and 500 millimeters. After entering the values, click Compute. The simulation has successfully completed for all 3 specified lengths. Let's review the stress results for the 200 millimeters pipe length. As you can see, the pipe geometry updates live in SolidWorks during each step of the solution. Make sure the geometry and sketches in SolidWorks are fully defined, or this feature may not work as expected. This concludes the tutorial. Thank you for watching.